Good morning everybody, myself Acharya Vishvendra, and today I am before you to give the solution of quiz of the day today. The topic of concern here is electric field, and you are being given a ring with center C and radius R, and there is a point P at a distance of x from the center of the ring, and charge is uniformly distributed, total charge is Q. So the first question here is, what is linear charge density on ring? So we know that linear charge density is equal to charge divided by the length. Now length here will be the circumference of the ring, and we know that circumference is 2 pi r. So we can say that lambda will be q divided by 2 pi into r. Now let us elaborate this expression of lambda for the graphical relations. So the first question is, lambda is proportional to q. So if we draw the graph between lambda and q, we can say that it will be a straight line. And second elaboration can be lambda versus r. So we can say that lambda is proportional to 1 by r. So if we draw the graph between lambda and r, it will be a rectangular hyperbola. So that will be a rectangular hyperbola. Third thing is possible, if we draw the graph between lambda and 1 by r, it's a bit tricky. So what you do is that lambda is proportional to 1 by r. You take 1 by r as equal to x. So the relation comes out to be lambda is proportional to x. Now suppose here it's not 1 by r, take it as x so that things become easier for the comparison. Actually what happens is in the brain there is an image that lambda is proportional to 1 by r, so graph will be rectangular hyperbola. So whenever x's are not straight, they are something else. So the best way is assume that as equal to x. So here assume that lambda is equal to x, then deduce the relation that lambda is proportional to x. So here also the graph will be a straight line like this. So this is answer of the first question. Now let us see maximum electric field on P. So you see that expression for electric field at P after integration is, this is your kqx divided by x square plus r square raised to power 3 by 2. So the expression is like that. Now this expression involves x as it's a function of x. To find maxima you need to differentiate it and put dE by dx is equals to 0. When you differentiate this expression, it gives the solution as x is equals to plus minus r by root 2. So the electric field is maximum at x is equals to plus minus r by root 2. Now if you substitute the value, then EP comes out to be kq into r by root 2, and here it will be x square will be r square by 2 plus r square. So that will be 3 by 2 r square raised to power 3 by 2. So that will be kq r by root 2. Then here will be root 3, obviously 3 root 3 by 2 root 2 into r cube. So that will give us r square, and the maximum value will be, we can write it as kq by root 2. Here it will be 3 root 3 r square, and here it will be 2 root 2. So it will be twice kq by 3 root 3 r square. So that will be the maximum value of electric field at P. Now is the minimum value. So obviously this will be minimum when x is 0. So we can say that EP minimum will be 0, and electric field maximum value will be 2 kq by 3 root 3 into r square. If we want to simplify k, we can write it as twice 1 by 4 pi epsilon naught into q by 3 root 3 r square. So that will give us q by 6 root 3 pi epsilon naught into r square. This is another analogy for this. So this is minimum value is 0 and maximum value is equal to this. There is one more interesting thing. If we see for the graphical variation of E versus X, so the graphical variation is like this, and it has got its maxima at r by root 2, and the maximum value is this 2 kq by 3 root 3 r square. So this is the graphical variation possible for this. So in this way you have seen that a number of questions can be asked from a simple concept. The purpose behind quiz of the day is to give you some out of the box question in which you need to think randomly out of the random topics, which is a testing of your mind brain system, that how much time do you require to retain information from your mind brain system. For more questions, you can ask me in the comment section. Thank you and have a nice day.